Welcome back, everyone. Let's go ahead and test your new skills on recurrent neural networks through an exercise. In this lecture, we'll just do an overview of the exercise notebook, and in the next lecture, we'll go through the solutions. Let's get started. All right, here I am at the exercise notebook. This exercise should pretty much feel very similar to the previous lecture. We're essentially asking you to, given a time series, and this time series is kind of a fun one. It's frozen dessert production, and it's from the Board of Governors of the Federal Reserve System, again, that FRED data set. If you want to figure out all the information on it, you can click on this link, but we keep track of the industrial production of ice cream and frozen desserts. So clearly there's a seasonality to this, and notice that the seasonality is based on the summer months, because when it's hot outside, you usually want some ice cream. So kind of a fun data set to play around with here. And if we come back to the exercise, what you're going to be doing is essentially the same series of steps that we did in the previous lecture. So feel free to reference the previous lecture, although try your hardest to do this, maybe not from memory, but from Google searching on your own and not referencing the code in the previous notebook precisely. Instead, try to see if you can think about it on your own, see if you can figure out those loops on your own, etc. That'll be really helpful for you. But as always, you can always reference our previous notebooks if need be. So we ask you to read in the data and then go ahead and rename the column to make sure it's easier to read, plot out the data, and then do the train test split. You have a lot of flexibility here on figuring out the length of the data set, but the test set should be at least the last 24 months of data. Again, you can always play around with this and make it less. It's up to you. You can make 18 months of data. Then we want you to scale the data and then create the time series generator object, create the model. And again, you have all the leeway you want as far as LSTM units. You can see what we actually used here. We used 100 LSTM units, very similar to the lecture. Then create a generator for the test set and validation set. The main thing to note here, and this is where you actually may get in a little bit of trouble, is the length for that test validation generator. Recall that the batch length needs to make sense for the size of the test set. So we mentioned that in the previous set of lectures, and basically the main thing to note here is that the length of your actual batch size, it has to be less than the length of your test set. Because if you have a batch length that's the exact same length as your test set, you won't be able to grab that extra forecastable point into the future. So if your test set, for instance, is 1 month and your batch length was 1 month, you need the extra month in order to forecast 1 month into the future. So again, make sure that your batch length is less than your test length. Okay, so we discussed that in the previous lecture, so go ahead and review that if you have any trouble creating that validation generator. Then we want you to create an early stopping callback. Go ahead and fit the generator using that early stopping. It should end around 10 epochs or so. Plot out the history, so you'll see that it's pretty noisy in the beginning, but then starts to flatten out. And then we want you to evaluate on the test data. So go ahead and get the production, the predictions, etc. And in general, you should be able to at least get a model that more or less shows the trend. You may fit a little better, a little worse than this due to the random initializations of the recurrent neural network, but your model should at least be able to tell that during the summer it tends to peak and during the winter it tends to go down. If you got a model that got that general trend, then you should be pretty good. Okay, and then the last tasks, and this is something we actually didn't show you how to do, but I know you know how to do it based off what we learned throughout the entire course, is calculate your root mean squared error on this actual data set. So if you get stuck on this, you can go ahead and check out the solutions, but you should be able to do it given everything we know about scikit-learn, test versus predictions, etc. Okay, so coming up next, we're going to go ahead and go through the solutions. I'll see you there.